All right, so here we're given a function as a table. All right, so we just have data. So how in the world do we figure out what's happening with the first derivative or second derivative when all we have is data? All right, so that's what we're going to talk about in this example. So the first question is, does the derivative of this function appear to be positive or negative? All right. Now remember, if the derivative is positive, that means the function is increasing. If the derivative is negative, right, the function is decreasing. So what do I see here? You know, the values of the function as t increases, the values of the function are getting bigger, right? 75, 100, 120, 135, and so on, right? So because g of t is increasing, all right, we would expect g prime of t to be positive, greater than 0, right? Positive. Okay. Right? And then, we just have a few data points. So, um, but that's, I think, a good estimate is that we would expect the derivative to be positive because the function is increasing. Okay. Now we don't know what's happening in between. Maybe it, maybe it doesn't, maybe it increases and decreases. But given the data that we have, it looks like the derivative is positive. And then it's asking us, does the second derivative of this function appear to be positive or negative? Okay, well, there's no function to take the derivative of the derivative. In fact, we don't even have the derivative. All we know is that the derivative is positive. So how could we figure out what's happening with the second derivative? All right, so remember, if the second derivative is positive, then the derivative is increasing. Okay? And if the second derivative is negative, then the derivative is decreasing. So we can sort of use average rate of change as a proxy for the derivative. So if we find average rate of change, so the change in this g divided by the change in t, right? We could look at these different intervals here. Let me that's up here. So I could look at this interval from t equals 10 to t equals 20, and I could calculate the average rate of change. And that's a good proxy for the derivative. And then if I look at what's happening with the average rate of change, that'll give me an idea of what's happening with the second derivative, right? So let's do that. If we look at the difference here, it's a 25 unit increase over a 10 unit time interval. So that's 2.5. Right? So the average rate of change over that interval is 2.5. So if I look at the next interval, it's an increase of 20 over a change in t of 10. So we have an average rate of change of 2. This one, there's an average rate of change of 1.5. And this has an average rate of change. It's basically 10 over 10. So that's just 1. Okay? So these average rates of change are a good proxy for the derivative. And you can see that these average rates of change are decreasing, right? The average rate of change is decreasing, right? So the average, let me write that down, average rate of change is decreasing, right? Decreasing. Okay, so that tells us that the derivative is decreasing, right? And when the derivative is decreasing, that means the second derivative is negative, right? So f, whoops, not f, it's g, right? So g double prime of t is less than 0, right? So it's negative, right? And I can tell that if I use average rate of change as a proxy for the derivative, right? So if the average rate of change is decreasing, then the second derivative is negative. Okay? Does that make sense? All right, I'll meet you in the next video.